The Magic of Nabu, Babylonian Astronomy in Practice. Imagine walking through the streets of Babylon 2,500 years ago. Merchants are trading goods, priests are climbing temple towers, kings are making decisions that will shape empires, and somewhere above them, the planets are moving silently across the night sky. Most people see wandering lights, but a small group of Babylonian scholars see something very different. They see patterns, numbers, cycles, predictions. And for the first time in human history, they are beginning to answer a question that would eventually lead to modern astronomy. Can the future movements of the heavens be calculated, not guessed, not interpreted, calculated? Long before telescopes, long before Newton, long before modern science, the Babylonians were developing mathematical tools that allowed them to predict celestial events years in advance. This is the story of how humanity learned that the sky was not just observable. It was, in large part, predictable. In our last episode, we explored how Mesopotamian civilizations began systematically recording the heavens, night after night, year after year, generation after generation. They created humanity's first astronomical databases. But there was still a major limitation. Observation alone cannot explain the future. Imagine tracking the moon for decades. You know it follows a pattern. But can you predict exactly when an eclipse will occur? Can you determine where a planet will appear months from now? Can you calculate celestial events before they happen? The Mesopotamians had gathered the data. The Babylonians would learn how to use it, and that changed everything. By around the first millennium BCE, Babylon had become one of the intellectual centers of the ancient world. Its scholars inherited centuries of observations collected by earlier Mesopotamian civilizations. But instead of simply recording the heavens, they began searching for mathematical relationships hidden within them. This was revolutionary. For perhaps the first time in history, humans were trying to describe celestial motion using numerical patterns. The Babylonians discovered that planets did not move randomly. The moon did not move randomly. Everything followed cycles, and cycles could be calculated. This was the beginning of predictive astronomy, not mythology, not philosophy, prediction. To understand Babylonian astronomy, we need to understand Nabu. Nabu was the Babylonian god of wisdom, writing, and knowledge. He was believed to record the destinies of gods and humans. In many ways, Nabu symbolized the Babylonian belief that knowledge could reveal hidden truths about the universe. The scholars who studied the heavens were not merely sky watchers. They were interpreters of cosmic order. They believed the heavens contained information waiting to be decoded. And unlike many earlier traditions, they increasingly relied on calculations rather than stories alone. The sky was becoming a mathematical puzzle, and Babylonian scholars were learning how to solve it. This was the Great Babylonian Breakthrough. Earlier civilizations discovered patterns. The Babylonians learned how to forecast them. Imagine observing the moon for centuries. Eventually, you notice that eclipses seem to repeat, not perfectly, but often enough to suggest a cycle. The Babylonians identified a recurring eclipse period of roughly 18 years and 11 days. Centuries later, astronomers would name this pattern the Saros cycle, though the Babylonians themselves used a different term for it. Using this cycle, Babylonian astronomers could predict lunar eclipses with real confidence and could identify the specific months when a solar eclipse somewhere on Earth became possible. Knowing exactly where on Earth a solar eclipse would be visible was still beyond their mathematics. That problem would not be solved until many centuries later. But even this partial power was extraordinary. Most people viewed eclipses as terrifying supernatural events. The Babylonians were among the first to treat them as events that could be anticipated in advance, at least in part, rather than feared as random omens. The heavens were becoming understandable. For the first time, humanity could look into the future using mathematics. One of the most important figures in this story is Naburimannu. Although much about his life remains uncertain, his work represents a major milestone in Babylonian astronomy. Naburimannu helped refine mathematical descriptions of lunar motion. The moon was enormously important. It governed calendars, religious festivals, agriculture, timekeeping. Understanding its movements meant understanding time itself. His work demonstrated something remarkable. Celestial movements could be represented numerically. The sky could be translated into mathematics. This idea would become one of the foundations of modern astronomy. Then came another extraordinary figure, Kidinnu. Many historians regard him as one of the greatest astronomers of the ancient world. Kidinnu refined measurements of lunar cycles with astonishing accuracy. Some of his estimates differ from modern values by only tiny amounts. Think about that. No telescope, no calculator, no computer. Yet ancient Babylonian astronomers were producing measurements precise enough to impress modern scientists. Kidinnu's work improved calendar systems and strengthened predictive astronomy. His calculations would influence later Greek astronomers and continue shaping astronomical knowledge for centuries. The sky was no longer just being observed, it was being measured with precision. The Babylonians also made remarkable progress in tracking planets. To earlier observers, planets appeared strange. Unlike stars, they wandered, sometimes moving forward, sometimes appearing to move backward. Their behavior seemed chaotic. Babylonian astronomers discovered it wasn't. By carefully recording planetary positions over long periods, they identified recurring patterns. They tracked Mercury, Venus, Mars, Jupiter, Saturn, the 5 visible planets known in antiquity. Over time, they developed methods capable of predicting where these planets would appear in the sky. This was a huge leap forward. Humanity was beginning to understand that even seemingly complex celestial motion followed hidden rules. Today, prediction is the heart of science. Scientists build models, models make predictions, predictions are tested. The Babylonians were among the first people to apply this logic to the heavens. Instead of simply asking, "What happened?" they began asking, "What will happen next?" That shift transformed astronomy forever, because prediction requires something powerful. It requires confidence that nature follows rules, and once you believe rules exist, science becomes possible. The influence of Babylonian astronomy spread across the ancient world. Greek astronomers inherited Babylonian observations and mathematical techniques. The famous astronomer Hipparchus relied heavily on Babylonian data. Later astronomers built increasingly sophisticated models of planetary motion. Scholars of the Islamic Golden Age, including many Persian astronomers, preserved, translated, and refined these traditions even further. European scientists eventually used these foundations to develop modern astronomy. The path from Babylon to modern space science is long, but it is unbroken. Every generation added another layer of understanding. The Babylonian legacy surrounds us. Whenever scientists predict an eclipse, they are participating in a tradition that began with Babylonian eclipse calculations. Whenever astronomers forecast planetary positions, they are building upon methods first explored in ancient Babylon. Modern observatories still rely on the same fundamental process: observe, measure, model, predict. Space missions use mathematical models to determine where planets will be years into the future. Satellite operators calculate orbital paths. Astronomers forecast celestial events decades in advance. The tools have changed, the mathematics has evolved, but the underlying idea remains the same. The future movements of the heavens can be calculated. That idea was one of Babylon's greatest gifts to humanity. So, what did the Babylonians add to humanity's understanding of the sky? Before Babylon, people recorded celestial patterns. After Babylon, people could predict many of them. Before Babylon, astronomy was largely observational. After Babylon, it became mathematical. Before Babylon, eclipses inspired fear. After Babylon, they became events people could anticipate, using mathematics instead of myth. The Babylonians transformed the heavens from a record of the past into a guide to the future. And that changed everything. Because once humanity learned that the universe could be predicted, a new possibility emerged. Perhaps the cosmos itself operated according to discoverable rules, a question that future civilizations would spend thousands of years trying to answer. And in our next chapter, we'll travel to ancient Egypt, where the sky would become something even larger than a mathematical system. It would become a reflection of cosmic order itself.